Hey everybody, we're talking about some topic 14 notes today. This is going to be what qualifies as our 14-5 notes. It's not going to take very long, and there's not any problems associated with just this stuff. So just make sure you're filling in the blanks and following along and understand what we're talking about. Okay, what we're talking about today is sort of an intro to what we're doing for sections 6, 7, and 8 of topic 14. Okay. Section 6, we are going to talk about cylinders. Okay, so a solid cylinder, first off, that is a solid 3D figure. It has two parallel bases that are congruent circles. Okay, I think everybody has a pretty good handle on what a cylinder is. There's a nice little diagram of it right there in the bottom left of the screen. Okay, everybody knows inherently at this point, by the time you get into high school geometry, what a cylinder is. The radius of the cylinder. Okay, there are two things when we talk in the next lesson about the formulas for how to find the volume and surface area of a cylinder. The two things you're going to use the most are the radius and the height. The radius of the cylinder is the same as the radius of the base. The height is the perpendicular distance in between those two parallel circular bases. Okay, so you're going to see in the next lesson that in a lot of ways, in a lot of different ways, everything that we do with cylinders is going to be very similar to what we did earlier on in topic 14 with prisms. All right. So basically, a cylinder, we're going to treat it like a circular prism. Okay. When you deal with a cylinder, one of the things that we're going to talk about is surface area, like we've been doing. And so if you took a cylinder and you sliced it down the height, okay, just right down the side, directly straight down, you would unroll it and unfold it out, flatten it all out, and you would have the two circular bases. You would also have this rectangle. That rectangle is what wraps around the circular bases that makes that curved surface in between them. Okay, and what's really fun, and this is actually where the formula for surface area comes from, is that this outside of the circle right here is what lines up with this top side of the rectangle. So if you're looking for the area of this rectangle, you would need the height of the cylinder, the distance in between the bases, and you would multiply it times the circumference of that circle because that's what lines up with it. Okay, we'll talk about that in the next lesson. You'll see that that is part of the formula. All right. Moving on now to talk about cones, and that's what's going on here. A cone has a circular base, it has a curved lateral surface, and one vertex up at the top. Okay, for all intents and purposes, as we talk about cones later on this week, you will see that a cone is basically the same as a pyramid. It just has a circular base. Okay, kind of like a cylinder is a circle prism. A cone is a circle pyramid. All right, so the height of a cone is going to be the distance from the vertex down to the center of this, like on a pyramid, and the slant height is going to be the distance from the vertex down the outside of the lateral surface to the base, also just like a pyramid. Okay, so when we talk about the volume and surface area of cones later on this week, you're going to notice the differences between height and slant height. Just like on a pyramid, you can't mix those two things up or you will get wildly different answers. All right, so be on the lookout for that. The net of a cone, it ends up being when if you were to slice a cone down its slant height and unroll it and unfold it all out, you've got the circular base and the curved lateral surface flattened out like there, right there. It ends up being part of a circle, is what it looks like. Okay, it's like a wedge of a circle. Okay, and this length right here ends up being the slant height. Okay, the radius of that piece of circle is the slant height, and you'll see that later on that is actually what plays into the formula for surface area on a cone. All right, moving on now to our last one. This is a sphere. Sphere. Okay, is my least favorite word in all of mathematics because it starts with sph. Y'all, that is just ridiculous. Who does that? Why would you start a word with sph? Anyway, um, A sphere has a curved surface. Okay, in fact, a sphere is all curved surface. That's how you define what it is. It's kind of like a circle. In a two-dimensional circle, every point that's on the circle is the same distance away from the center, and just in that exact same way, every point that's on the surface of a sphere is the same distance away from the center point. That distance, just like on a circle, is called the radius. And if you slice a sphere in half, you will get two things that we know the word from geography. Okay, like the equator cuts the sphere of the Earth into the northern and southern hemisphere. So a half of a sphere is called a hemisphere, as we see right there in that picture. All right. Now, I believe that is all of the notes for today. It is. So, on that note, be on the lookout for all three of these items in our next three lessons. That's what we're going to be dealing with. All right. Y'all have a good one.